Hi, welcome back. Welcome to Unacademy. Unacademy is the India's largest online learning platform. So I'm welcoming you all to this beautiful online learning platform. Now we are happy to announce that Unacademy is going to providing a support to the students who are appearing for GATE and service examinations, engineering service examinations. About myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada, and my specialization is VLSI. Now, see, first we check how to get Unacademy learning app into your device. If it is in your device, it's okay. Otherwise, install it. Just go to Play Store and type Unacademy on that. Type Unacademy. After typing Unacademy, just click on this install button. It will install the Unacademy learning app into your device. Unacademy learning app into your device. Okay. Now, once you open that Unacademy learning app in your device, it will shows different courses which are available in that, and in each course, each subject is handled by which faculty, and you can get a brief introduction about that faculty also. Okay, now the top faculties are available in Unacademy. Okay, if you observe, here are some top educators, top faculty from Unacademy. See this? He is Tiwari sir, he is IIT topper. Ankit Goyal sir, he is the 2 times All India rank first, 2 times All India topper in GATE electrical. Okay, Jaspal Singh sir, he is the ex-IAS officer, he got All India 4th rank in IAS. And Jain sir, he is the top faculty from CSC department. Okay, and a few more faculty are here. Okay, from different departments. Now we are happy to announce that recently we started 2 batches for GATE 2022 and GATE 2023 in different disciplines. See, in mechanical engineering, there is a new batch, Ascend batch for GATE 2023. For GATE 2023. Okay, and here are the top faculty who are handling the subjects in this department. Okay, now this batch started from 8th February 2021. Next, there is a eval batch for GATE 2022. This batch also for mechanical engineering. This is started from 8th February 2021. And my dear students, don't forget to use my code during subscription, VRAW10. VRAW10. Please use this code during subscription. You get 10% discount by using this code. Next, there is a Ascend batch for GATE 2023 for civil engineering. This batch started from 8th February 2021. So here are the top faculty who are handling these subjects in civil engineering. Next, again for civil engineering, but this time this is for GATE 2022 eval batch. This batch started from 8th February 2021. Here are the top faculty who are handling the subjects in this. Next, there is a eval batch for GATE 2022. Eval batch for GATE 2022. Okay, here are the top faculty who are handling the subjects of computer science and information technology. This batch started from 8th February 2021. Okay, and now we are moving to electrical and electronics engineering side. Now this is the electrical department. In electrical, there is a Ascend batch for GATE 2023. This batch started from 1st February 2021. Here are the top faculty who are handling the subjects in electrical engineering. Next, there is a Ascend batch for GATE 2023. Ascend batch for GATE 2023. This is for electronics and communication engineering. Okay, here are the top faculty who are handling the subjects in electrical and electronics engineering, electronics and communication engineering, sorry. This batch started from 1st February 2021. And my dear students, don't forget to use my code during subscription VROW10. By using this code during subscription, you get a 10% discount. Okay. Next, there is a eval batch for GATE 2022. This is for electrical engineering. Okay, this batch started from 1st February 2021. So here are the top faculty who are handling the subjects in this electrical engineering side. Okay, electrical engineering department. Next, again we are moving to electronics and communication engineering. This is for GATE 2022. This is the eval batch. Okay, this batch started from 1st February 2021. Next, again there is a eval batch for GATE 2022. This time this is for chemical engineering. Some of you may wonder by seeing this one, chemical engineering. Why? Because at outside it is very difficult to get the chemical engineering department. Okay, very few locations you get the training for chemical engineering. Okay, now the chemical engineering, if any of your friends are in chemical engineering, please inform this one to them. This is very helpful to them. Okay, this batch started from 25th of January. Okay, here are the top faculty who are handling the subjects in that. Now we are moving to different disciplines. Once again I am repeating here. There is a mechanical engineering, electrical engineering, civil engineering, production and industrial, instrumentation engineering, chemical engineering, computer science and IT department, not but not least electronics and communication engineering. These are the different disciplines available for GATE and service examinations from Unacademy. Okay, now here we have two types of subscriptions. First one is a plus subscription. Plus subscription is the basic plan. Second subscription is iconic subscription. It is the next level of the basic plan. Here we provide personal coach to you. This is the important thing. Personal coach is going to play an important role in your success. Okay, I will explain how he is going to play important role. Both the cases, the common thing is India's best educators are going to take your classes, interactive live classes. Okay, and structured courses and PDFs are available. Both the case. Now there are live tests and quizzes. See, once live tests and quizzes are completed, generally students are doing one mistake. Don't mind otherwise. That is, once test is completed, simply they see their response in that. Okay, if they get 30 marks or 40 marks, they will improve their preparation. If they get 60 marks or 70 marks, some of the students neglect it. But very few students, whatever the marks they got, even they got 80 marks out of 100 or 30 marks or 20 marks, whatever the marks they got, very few students refer the question paper and whatever the answer they given, and they prepare a note on that where they are strong in that paper. Okay, where they want to do more preparation and where they committed a mistake in that, they prepare a note on that, short note. Based on that short note, they will continue their preparation by preparing a proper schedule. We call it as a study plan. Very few students, those students in final exam, they are not going to do such type of mistakes, because at every exam they done their planning properly, they done their exam paper analyze. Okay, analyzed, and they identified where they are strong and where they want more preparation, and where they are going to committing the mistakes. They know that. Now they will take care in the final examination without committing mistakes. They will write the exam. Okay, So those students get good scores. Okay, so in that intention we are arranging a personal coach to you. We will assign one personal coach to you. His duty is, once you've written a test, he will analyze the test. Okay, he will write the positives and negatives in the test what you've written. Based on that, they will prepare a study planner to you, proper study planner, and proper study material to you. By following these two, definitely you will get success in your examinations. Okay, so completely he is going to analyze your paper, your knowledge, what you are putting your knowledge on the paper. He knows about you more than you, where you are strong, where you are doing mistakes. That is the most important thing. See, you observed or not, who are attempting the GATE, nearly 50+% of the students, okay, are losing marks. Nearly 10 marks they are losing by doing a small mistakes. They know that marks, if you are giving a time and if you are giving some analysis, little bit time they spend on this, they get this 10 marks. Okay, but due to the tension, okay, and hurry, they are losing that marks. Okay, now here the personal coach intention is, first intention of this personal coach providing is, student has to gain these 10 marks. They can't lose their marks because they prepared that one, they prepared the topic, they know how to solve that. At that time, how can they lose the marks? That was taken care by the personal coach. So once you gain 10 marks, you protected your losing 10 marks. Now your rank is going to be difference of thousands. With that motive, we place a personal coach for each and every student in Iconic. Okay, now if you observe the cost for each and every plan, for a plus plan, the cost is depends on the subscription, how much time you are taking. For 1 month subscription, 5,500. This is for 3 month subscription. This is for 6 month subscription. This is for 12 month subscription. This is for 18 months, and this is for 2 years. And you observed or not, see, my suggestion is minimum take 1 year subscription, okay, to get a better result. Now if you compare this, after using my code VRAW10 during subscription, okay, you get that one with a cost of 27,225 rupees only. 27,225 rupees only. Okay, now if you compare this cost for see, you are spending this cost for 12 months, that means 1 year. For example, you joined somewhere outside for coaching of GATE. At that time, for traveling, for example, your classes are they are conducting the classes at weekends and during public holidays. At that time, for traveling from your home to that location and return, and during the class timing, you need to take some snacks, such type of things. Okay, if you add all these things throughout year, the cost of that one is worst case 20,000 plus. By adding a little bit amount more than this, you can get whatever the benefits you are getting there in your class, you get more benefits here. Just you are here spending the cost what is taken, excess expenditure, traveling expenditure it is. I am not saying about the fee what you are paying there, traveling expenditure. Just by adding 4 to 5,000 to that traveling expenditure, you can get the more benefits what you are getting in your classroom. By sitting at your home itself, please remember this, by sitting at your home itself. Okay, so please, my dear students, don't waste your time and your money. Okay, and moreover, your health is very important. At outside situation is not that much good. Okay, so please take a good decision. And this is about your plus plan, and we are moving to Iconic plan. Here only 2 subscriptions, 12 month subscription and 24 month subscription. Okay, in both the subscriptions there is a EMI option. In Iconic as well as Plus subscription, there is a EMI option. EMI option. Okay, so it is a 4,188 per month. In for 12 years, this is a cost of 50,000, 250 rupees per 1 year. After using my code, it became 45,225 rupees. 45,225 rupees only. Don't forget to use my code VRAO10 during subscription. After using this code, you get this one with this amount, 10% discount. Okay. So my dear students, whatever the thing is happened at outside, your learning process cannot be stopped. Okay. Now, here it is a more cost because we are providing a personal coach to you. That personal coach is going to be take complete your care. Okay. So please think once of it and don't waste your time. Join in Iconic plan and happy learning. Okay. Now we are moving to our today's topic, modeling of PN junction diode. Modeling of PN junction diode. So you may ask one thing, sir, what is the meaning of modeling of a diode? What is the meaning of this modeling of a diode? How we are going to model? We have a PN junction diode, that's it. Yeah, it is there. Okay, now already we know the VI characteristics of a diode. I'm going to starting from VI plot. This is the V and I characteristics of a plot. Okay. VI characteristics of a plot. This is the VI characteristics. And here we have V gamma, cut-in voltage. Okay. Now, from this VI plot, we are defining the relation between this current and this voltage by I is equals to I naught into I is equals to I naught into ID. Diode current is equals to I naught into e power Vd by eta Vt. Approximate value this is. Okay, minus 1 is there, but compared to the practical value, that is very small, we can neglect that. This is the, okay, if you want you can add it, no problem. This is the exact equation for diode current. Now here the relation between voltage and current is exponential. So ID directly we are writing approximate value is I naught into e power Vd by eta Vt. Okay, you can take eta is one regular cases. Okay, now here V and I are related by exponentially. Okay, but in regular case most of the things are linear in regular. Okay, I want to define my diode in a linear way. I want to represent my diode in a linear manner because it is exponential one. You may ask one thing, sir, how can we represent that in a linear way? See, I will show it. For that, I am taking one example. For example, here I have a diode. Here we have a circuit diagram like this. This is the circuit diagram. Here we have. Yeah. So let us, I am taking, this is the VDD, and the voltage across the diode is VD, and current through the diode is ID. This is R. Now this diode and the resistor both are in series. That's why same ID current is flowing through the resistor also. Now I want to calculate ID value. What is the ID? If possible, VD also. I want to get the value. Okay. Here there are two unknowns, VD and ID. So we need two relations between this VD and ID. Okay, then by solving those two relations, you can get the value of VD and ID. Okay, now from this circuit, I am going to writing first relation. So I am applying KVL to this. Just by applying KVL. By applying KVL. So I am applying KVL to this. By applying KVL, we can write VDD equal to drop across this diode is VD plus ID into R. ID into R. This is the equation. Okay. First, from this, I am going to estimating the maximum possible diode current and maximum possible voltage drop across this. See, when diode is short circuited, at that moment the maximum current is flowing through that. When diode is open circuited, that means current is zero. At that moment VD is going to be the maximum. Okay. Next we go to that next step. Let us take, this is the equation number 1. Equation number 1, that is. Okay. And after that, there is a voltage current plot for this diode. The IV characteristics of the diode is like this. This is the IV characteristics. IV characteristics. This is the plot, IV plot. Yeah. Here is some V gamma we have. V gamma. This is the IV plot. Voltage and current plot of this one. Here current through diode you are representing by ID. ID. So current through the diode we are representing by capital ID, and voltage across diode you are representing by VD. This is V gamma. Now from its VI plot we know one thing. From VI characteristics, we can write ID equals to I naught into approximate value I am writing, sir, e power VD by eta VT. This is the second relation. So this is the first equation and this is the second equation. Just by solving these two equations, you can get the value of VD and ID. Okay. For easy understanding purpose, let us take I naught 1 microamp, and we know the eta value. Okay, take eta also 1, and VD is at room temperature 25 millivolts approximately. Use that data. Okay, just solve these two. By solving these two equations, you can get the value of VD and ID. Okay. Now, how to solve those two equations? In regular way, this is not possible. Why? Because see this, just we are trying to solve this too. This is VD value. ID is from this VDD minus VD by R. Take that one, substitute here. After substitution, there you get VDD minus VD by R equals to I naught into L e power VD by eta VT. From this we have to separate VD and VD one side and remaining parameters another side. But because of this exponential, it is not possible to separate VD. Because if you are taking to separate this one, to remove this exponential, if you are taking natural log on both sides, then it is now free. It is linear one now, but it is became a linear ln of VDD minus VD by R. So simplification is not manually not possible. Okay, that is the problem. That is the problem. Okay, sir, is it okay? Now, for that, for simplification is not possible. Now, what we have to do? How can we solve that problem? See one thing, simple. Now, I am taking the plot once again. I am going to taking plot once again. Yeah, this is ID VD plot of your diode, and this is the plot. This is the VI characteristics, like this. So somewhere here you have V gamma. After solving that problem, see previously by solving these two you get one value of voltage and current. That means the voltage across the diode is somewhere here and the current through the diode is somewhere here. This is the current value and this is the voltage value we got in this one after solving these two. For example, manually not possible, so by using some special tools I solved it. Let us now, this is the, we called it as operating point. We call it as operating point. So that operating point is, let us take it as V comma I. V comma I is the operating point I got after solving those two equations previously. And here I am going to introducing another one, that is just a minute. Here I am going to drawing a line. Like this here. Now this is the maximum possible amount of current flow and this is the maximum amount of voltage across the diode. These are the 2 points, and this is the operating point, the point where you are going to operating your diode. Let us take this operating point is V comma I. This is the operating point. Now this value I want to get. At this point the voltage value VD is 0 at this point, and at this point on x-axis y coordinate ID is 0, and our equation, standard equation, what we get from the circuit diagram is VDD equals to VD plus ID into R. This is the equation what we have. Now in this I am taking, let VD equals to 0, because once VD equals to 0, at this point VD equal to 0, then you get maximum current flowing through the device, flowing through the diode. Now by substituting this one in that, you get VD 0. Now therefore VDD equals to ID into R. Therefore, ID is, that means ID is VDD by R. This is the maximum current flowing through the diode. Maximum diode current. Maximum diode current. So this is VDD by R. VDD by R. That is the maximum diode current. Next, similarly, now I am taking let ID equals to 0. Once ID equals to 0, now from this plot, from this equation, VDD equals to VD plus 0 into R. Therefore, VD equals to VDD. This is the maximum voltage across diode. Maximum voltage across diode. Maximum voltage across diode. Across diode. This is the VDD. Okay, now we called it as DC load line. We call this line is DC load line. What is DC load line? What is the importance of this? Everything we discuss at the time of transistor. Now, this is the, you are calling it as operating point. That means after solving those two equations, this equation and previous equation, what we have, diode equation, you get one value of voltage across the diode. This is the voltage and this is the current you get. That is, let us take V comma I. I got the value by solving those two equations. Now, with respect to this, we have one important thing. That is, here I am not considering this one and this one. Here two important points you need to consider is V gamma should be there. V gamma should be there. And this operating point should be there. So that means now I am going to defining my diode instead of this exponential way. See, this operating point should be there. I want to define that operating point. Okay. So just I am going to drawing a line to cross these 2 points like this. Now here what I am doing is, instead of defining the diode with this plot, I am defining my diode by this plot. With this exponential, I am going to defining by this linear. Okay. Now, because in this exponential there are two important points. One is V gamma, cut-in voltage, and another one is the operating point where your diode is operating. Okay. In this line also I have both the points. V gamma is there and operating point is there. Now I am changing this plot into this way. Like this. This is ID, VD, and your plot is defined like this. So defined plot is like this. This is your plot. Here this is V gamma, and this is the point V comma I, operating point, what you get. Okay. Now I am going to representing this line equation. So line equation for this one is y, our line equation, we know that y minus y1 equals to m into x minus x1. Okay, now the point equation, the point here is x coordinate and x coordinate is V gamma, y coordinate is 0. Here V comma I. Now I am taking, let us this is x1 y1 and this is x2 y2. X2 y2. This is the point. Okay, now so I am going to calculating the, substituting the values on y-axis. Here we have ID, Therefore id minus y1, y1 is 0, 0 equals to m. M is difference between y coordinates. That means here we know the m value, y minus y1 by, sorry, y1 minus y2 by x1 minus x2, or y2 minus y1 by x2 minus x1. Difference between y coordinates by difference between x coordinates. So y minus y2 minus y1 minus y2, or y2 minus y1. So now I am taking I minus 0 by v minus v gamma. Okay, sorry, yeah, v minus v gamma into x vd minus v gamma by rd. Now this plot is representing, I am representing this plot of v and I by, I am representing this plot by an equation. This is the plot representation. Now I am defining this plot by an equation, that is id is equal to vd minus v gamma by rd for v greater than v, for v greater than or equals to v gamma, and which is equals to id is 0 here. So 0 for v less than v gamma, for v less than v gamma, that means sorry, vd less than v gamma, vd less than v gamma. So that is the, this is the way of defining this plot in terms of equations, and the same thing represented in terms of a plot. Okay, so defining your diode in this format is called piecewise linear model. Piecewise linear model. So my dear students, this is very, very important. You may get there is a chance of getting problems on this. Okay, so once your diode is defined by in this model, then what we have to do is simple. Just our equation for id is vd minus v gamma by rd. Now I am writing this one. From this vd we can write v gamma plus id into rd. So the meaning of this one is, once you have a diode like this, once you have a diode like this, okay, now the current through the diode is id, and voltage across the diode is vd. In that, at that time you can replace your diode by its equivalent circuit, that is vd is equal to v gamma. V gamma is a constant voltage, constant DC voltage. It is V gamma. It is V gamma plus ID into RD. So here is RD, dynamic resistance, or sometimes we call it AC resistance. This is RD, and current through the diode is ID. Current through the diode is ID, and voltage across this diode is VD. So simply you can replace your diode by with this model. This is called piecewise linear representation. This is the equivalent representation of your diode. Okay. Now, immediately you may ask one thing. Sir, why are you taking this one with this slope like this? Why don't you take that one parallel to this y-axis? Why can't I place? Okay, you can place it. I don't have any objection. Now, I'm going to that. See. Now, this is ID. VD it is. This is the plot just before we drawn. Okay. Now, why don't we take this one standing it properly, vertically? Okay, you can take it. Now I am taking that one. Now this is my plot. Here is, this is V gamma. V gamma. See what we done here, whatever the plot we have like this, I am going to just modifying like this. Okay. Now, you may define diode like this also. The possibility is there. Why? Because initially you switch to your diode plot from its exponential to a little bit modification you done like that piecewise linear model. Okay, whatever the plot we have like some vertical like this, now I am keeping that one perfect vertical. That means now the slope of this one is infinite because it is parallel to the y-axis. Now your ID equation is previously in piecewise linear model. We defined ID value V minus V gamma by RD means dV by di for Vd greater than or equals to V gamma. Fine. But for this plot, delta V is 0 and delta I is some value, because initial I value 0, after that some value not equal to 0. Now V, see at t equal to 0, at ID equal to 0 its value is V gamma, at some ID value also its value is V gamma. So that's why delta V change in voltage is 0. Now just by substituting that, ID became V minus V gamma by RD is delta V, 0 by something is 0. This is for Vd greater than or equals to V gamma. Now this is something by 0 in infinity for Vd greater than or equals to V gamma. So ID is infinity for Vd greater than or equals to V gamma, and the remaining is 0 for Vd less than V gamma. So defining your diode with this equation is called, this is another way of defining your diode. In equation form you can define diode like this, in plot like this. This is called constant voltage drop model. Constant voltage drop model. Voltage drop model. Constant voltage drop model. In this case, whatever the dynamic resistance we have, the dynamic resistance is 0. Okay. So we observed here, whatever the RD we have, delta V by delta I, that is 0. Dynamic resistance is 0. Okay. Now its equivalent model is, how can I define its, represent its equivalent model? See this. Now, once your diode is like this, So this is the diode. Now once your diode is like this, drop across that one is VD, current through the diode is ID. In this case it is equivalent to 2. Whatever the ID we have 0. In previous case our equivalent diagram is this one, V gamma, here RD. But in this case your RD became 0. Your RD became 0. Okay, once RD is 0, simply it's short circuit. Now only V gamma. So its equivalent is simple, V gamma. This is V gamma. So this is the current through this ID. This is the voltage across this VD. That's it. This is called constant voltage drop model. Constant voltage drop model. Now you may ask one thing, sir, why are you keeping this line how much far, this much far distance from the exact y-axis? Why don't you merge this with y-axis? Okay, merge it, no problem. Now this is the plot initially we have. Now just before we have this plot. This is ID and it is VD. So we have a plot like this just before. This is our V gamma. Now I am moving me V gamma to up to 0. Now I am taking my plot is like this. So this is just here and like this. So previous case we made R0 0, RD 0. Now I made V gamma 0. Now this is my V gamma. This is your V gamma, new value of V gamma. So it means here just we shifted this one from here to here. Now we can find your ID is equals to, similar to as usual infinity, for VD greater than or equals to, your V gamma is 0 equal to 0 for VD less than 0. This is called constant voltage, ideal diode model. Ideal model or ideal diode model. Ideal diode model. This is the equation. In equation way of representation, you can represent ideal diode like this, and in plot point of view you can define diode like this. At that time the equivalent circuit for that one is, so once you have a diode like this, under ideal conditions you can replace your diode by, this is the current through the diode is ID, the voltage across the diode is VD. Now under this you can replace your diode by simply short circuit. So this is the current through the diode ID, voltage across the diode VD. Simple. This is the ideal diode. This is your diode, simply short circuit. Okay. In circuit point of view, you can replace, under ideal conditions, you can replace your diode by this equivalent. If you want to define your diode ideal way of representation by plot, by VI characteristics, you can use this plot. If you want to define the same diode by an equation for ideal case, you can represent that one by these equations. Okay, these are the representations. Now I am going to moving to a small signal model. Okay, before going to that, just we go for one problem. Okay, let us, I'm taking a circuit. Okay, I'm going to previous case. We have one. Okay, so this is the problem. They given here it is 10 volts. Okay, and the value of this one is 1 kilo ohm resistance value. So current through the diode is I, voltage across the diode is V. So they want to calculate what is the I value. What is I value? And at the same time they given the IV characteristics of diode is from IV characteristics of diode. Sticks of diode. They can define that I is defined as V minus 0.7 by 500 amperes. This is for V greater than or equals to 0.7 volts and equals to 0 amps for V less than 0.7 volts. Your diode is defined by these equations. Your diode is defined by these equations, and in this circuit your diode is operating. Now what is the value of I? Now they given four options. Option A is 10 milliamps, 10 milliamps. Option B 9.3 milliamps. Option C is 6.67 milliamps, and option D is 6.2 milliamps. These are the four options. Now see this. Now simple, just by seeing the plot itself it is observing, by seeing the equation, whatever the diode equation they given, VI characteristics of the diode, it is observed that now diode is defined in a piecewise linear model. Therefore it is piecewise linear model. It is piecewise linear model. Linear model. Simple. Once it is piecewise linear model, we know the equivalent circuit of the diode. If it is our diode, we know the equivalent circuit representation of piecewise linear model diode. It is V gamma and RD. This is RD. Just replacing this diode by this circuit. Now our circuit is, this is the given circuit. Now here I am replacing diode by its equivalent circuit. V gamma dynamic resistance RD. Yes, they given it is 10 volts. This is 1 kilo ohm. From this equation and this one, by comparing these two, this one and this one, V greater than V gamma, I is V minus V gamma by, our standard equation is I is V minus V gamma by RD for V greater than or equals to V gamma. By comparison, RD is 500 ohms, it is 0.5 kilo ohms, and V gamma is 0.7 volts, 0.7 volts. Just apply KVL to this. Now 10 is equals to, this is your I they given already, 1k into I plus 0.7 plus I into 0.5 k. So this is, from this I is 10 minus 0.7 by 1k plus 0.5k, 1.5k. 9.3 by 1.5k is 9.3 divided by 1.5, that is 6.2 milliamps. 6.2 milliamps. That's it. That is the answer. So in given options, your answer is 6.2 milliamps. This is the option. For example, in this problem, they taken RD equal to 0. RD 0 in this sense. See this. This is the circuit just before we studied. 10 volts, 1K, and your diode equivalent is V gamma into RD. This is 0.7 volts they given, and this is 0.5 kilo ohms. This is the circuit diagram. By solving this, we got I value 6.2 milli. Fine. For example, in previous analysis of diode modeling, just first we take RD value something, after that we made RD value 0. Now here also I am taking RD 0. Once by taking RD value 0, now just get the value of current I in this. It is 1K. Simply I is 10 minus 0.7 by 1K, that is 9.3 by 1K, 9.3 milliamps. This is the answer. So if you take this is the constant voltage drop model. If you consider constant voltage drop model, this is the answer. For example, I am taking ideal model. Let us assume ideal model we have. For ideal model, just I am replacing my diode by short circuit in ideal model. Replacing diode by simply short circuit. This is our ideal model. And current through this one is I. It is 10 volts. It is 1K. From this I is 10 by 1K. That is 1 milliamp. Sorry, 10 milliamps. This is the case for ideal model. So this is the answer if your diode is defined in an ideal model. This is the answer if your diode is defined in a constant voltage drop model. Okay, constant voltage drop model. And this is the answer if your diode is defined in a piecewise linear model. Okay, the left one is this one. If your diode is the exact model, that means exponential. So in exponential, you get this one. This is the exact value. Exact value is this one. Okay, but to get that exact value, it is very difficult manually to solve that. We need a special tools for that. So because of that reason, we are modeling our diode according to our convenience. Now we got different values. Okay. So which value it is depends on the way how you are defining your diode, way how you model your diode. This is the diode modeling. Now I am going to doing some little bit modification here. I am going to applying small signal to the diode. That means here is your diode. Okay, here is your resistance. Now here I am going to applying a small signal. Small signal I am applying, and some DC voltage. See this. Just before we completed this one, just before we completed, here we applied some DC voltage. Some DC voltage we applied. V. Okay, VD, let us. Some current, this is R. Some current is flowing through this. Okay. Now, so due to this, you get some current flow through the diode ID. Some voltage drop across this. Now, what I am doing is, I am going to maintaining. So I am maintaining some small current, small signal I am going to be applying. Okay. See, in this I am applying a small signal Vd of t, a very small signal, sir. It is, don't forget, it is very small signal. So very small signal. Okay, now this is of the order of 5 millivolts or 10 millivolts, like that. Now in this case, for a very small signal, now small current flow you get through the diode, small signal current flow. At the same time, small signal voltage drop across the diode. Here, practically it is possible. Practically it is possible, but it is not possible. Because this small signal is not having capacity to drive your diode. That is not having capacity to drive your device. Okay. So that is the problem with that. How to solve it? For that, the way how you are going to come college on a vehicle, okay, the way how you are going to college on a vehicle, same way I am taking the small signal, keeping on a DC signal. Keeping on a DC signal. Now, here, this is your vehicle. This is your small signal. Just I am superimposing small signal on a DC voltage. Like this. This is the DC voltage what we have. It is easily operate your diode. Now, small signal superimposing on that. That is the small signal modeling. Like this. Okay. Now, this is Vd, small Vd of t, and this is capital Vd DC value. Okay. And due to this small signal, small current is flowing through that, and due to this DC, capital ID is flowing through this. Okay. Now I want a small signal current. How much? Due to this signal. First of all, the total voltage what you are applying to the diode is capital Vd plus small Vd. Now for my easy understanding, now I am representing Vd of t by small Vd. Okay. Now we have the diode current equation. Now that current equation is, diode current equation is, diode current equation is, we know it, ID equals to I naught into e power Vd by eta Vt. We know that. But in this case, total diode current is capital ID plus small id. So we can call it small I capital D. This composite signal, mixing of DC value, small signal, I am representing it as a small I capital D equals to I naught into e power, total voltage across the diode is capital Vd plus small vd by eta Vt. Okay, now I am simplifying this. So capital ID plus small id is I naught into e power Vd by eta Vt into e power small Vd by eta Vt. So now this value I naught into e power capital Vd by eta Vt can be written as capital ID. Therefore it is capital ID into e power Vd by eta Vt. Just before you mention, Vd is a small signal, small value or small signal. That means Vd is much less than or less than eta Vt. Okay, so at that time you can define it is in the form of e power x, x is small. Then you can write e power x can be written as 1 plus x if x is small. If x is small, you can define e power x as 1 plus x. Now I am defining the same way here. It is a capital ID into 1 plus x. X means small vd by eta vt. This is a capital ID plus small id. Capital ID plus small id. Now, see here. This capital ID sorry. Now just simplify this. Therefore, capital ID plus small id equals to capital ID into 1, it is capital ID, plus capital ID into small vd by eta vt. So now capital ID gets cancelled. Therefore, from this small signal diode current, small id is capital ID by eta vt into capital ID by eta vt into small signal input voltage vd. From this I am defining small signal output current by small signal input voltage is defined as a transconductance GM, that is ID by eta vt. Eta vt. This is transconductance. Okay. Now whatever the thing we represented here, the same thing I am representing on a plot. Same thing I am representing in its plot. Small value. How the small signal is affecting. So this is a VDID. It is ID. It is VD. And this is our plot. This is our plot. Yeah, it's okay. Now, this is the DC voltage what I am going to be applying, and this is the whatever the DC current we got, capital ID, and this is the capital VD. Let us, for my better understanding, I am taking it as capital V, and this is capital I. This is capital I, and this is capital V. So we are superimposing a small signal on this. So let us, I am superimposing this signal on this in this region. By superimposing this signal on this, a small increment. See this. Small change. Initially DC value. Once input signal is increasing, voltage also increasing. Decreasing. Input signal decreasing. Input signal decreasing, toward net voltage across the diode decreasing, decreasing. This is the small signal what you are applying. It results there is a large current across the device, through the device. This is the large current. Okay, so this is the operating point. So like this, when you are applying a small signal to the diode, only small signal applying is not possible practically. So it has to be superimposed on a DC signal, and then you have to apply that one to your device. Okay, then you get a resultant DC current plus small signal current, and just before we defined whatever the small signal current we have in terms of DC current we defined. Small ID is capital ID by eta VT into VD. So we have problems on this. Next session we solve the problems on this, later sessions. Okay. Now, thanking to one and all for spending your valuable time with me. Now this is my code VRAO10. Don't forget to use my code during subscription to get 10% discount. And please click on this bell symbol to get the notifications, and join our Telegram group to get the latest updates of our upcoming videos. And don't forget to subscribe. Please give your valuable comments on YouTube to strengthen ourselves and to provide a better quality data to the upcoming students. Now, once again, I'm thanking to one and all for spending your valuable time with us. And I'm welcoming you all once again to Unacademy, India's largest online learning platform. Thank you. Thank you very much.